thanks everyone for joining. I think looking at the attendees, I think we have most people. We might get a few filter in, but they seem to have leveled off. So we can get started. So I want to thank everyone first for joining our first of a new series that we're starting, a learning series on different kinds of topics. On the first being on zero-emission buses and looking at where you can start and how to get started with zero-emission buses. So just a little bit of a background, we wanted to start in this area and do something for people who, or systems who maybe aren't sure or are looking at tackling some very practical problems around how to start with zero-emission buses. So where do I go first? What are the things I have to consider and how do I do that? So just to give everyone a little bit of an outline as to how we're going to manage it, we have a couple presentations. They'll be fairly brief. We're just trying to give you a basic overview of where these systems are. And the idea is we want this to be very attendee led. So after that, we'll just open up the floodgates to questions. So we're hoping for lots of questions. We want to answer your questions and this to be a venue where you guys can ask a couple of systems who have been through a lot of these processes around electric buses, have been through procurement and planning and all these different processes. It's your chance to ask. So throughout the whole thing, feel free to ask questions. We do have a Q&A session. That's the most ideal place. So feel free to put your questions there at any point. So don't wait. We'll gather them and we'll organize them, put them as they come. We want as many questions as possible. So if you have anything on your mind, feel free to put them as the presentation goes. And we have people to organize them and plan them. And so the presentations will be short, and then we'll go straight into the Q&A and have a bit of a discussion. So I'll do a bit of a brief introduction for our speakers today. So first we'll have Norman Hendry from Edmonton Transit Service. He's been part of the rollout right from the beginning. So I'll let him do a bit of an introduction when he gets on, but I hope you guys will find it very interesting. And then the other two speakers we have are from STM in Montreal. We have Geneviève Lemaire and Pascal Renaud. So they'll be following Norman going up. So with that, I will pass it off to Norman. And Norman, whenever you're ready, you can share your presentation and take the reins.
Okay, so good afternoon, and hopefully you can all see my screen. If someone could let me know you can see it.
Yeah, looks great.
Excellent, thank you. So yeah, I want to say thank you to giving me the privilege and the opportunity to share our electric bus journey. For those that don't know, we've actually got 40 Proterra electric buses in service here in Edmonton. And it was a long journey before we got to actually deciding on which bus we've got. So I'll just go straight into my presentation and take you through it. Now, this one just says background. It's nothing exciting to look at. But the background was a lot of work. And we started with, what do we want the bus to do, rather than what bus was available. So when I talk about what do we want the bus to do, we had to look at, do we want to have the bus as a bus? And what I mean by that is, where we've got diesel buses operating, we want the electric bus to do the same. Or did we want to have a fleet within a fleet? So we have dedicated routes for the electric bus. And we quickly came to the realization that we did not want a fleet within a fleet. So we wanted an electric bus that would do, at a minimum, 80 to 90% of the routes that a diesel bus would do, because we know that there's not a diesel bus out there, an electric bus out there that can do the distance or the time that a diesel bus can. So using that as our foundation, we then went on to the infrastructure. So we looked at the infrastructure from what the utility grid could provide. Was there enough power on the grid available at the 4 locations we've got, 4 service garages? And if it was available, how much was available? And if it wasn't available, didn't mean we had to put in another transformer station or upgrades. And then we looked at the building itself. Was the building capable of supporting a pantograph system? Because we're using pantographs because we went for long range, high capacity buses. So we quickly found out that 2 of our garages could not support pantographs. If we tried supporting them from the roof, the roof would fall down and the walls would collapse. So that kind of limited where we could actually put our pantographs in. So that gives you a little background of what we want. And then as we were going through, you know, we didn't want a fleet within a fleet because it would impact layover time if we were doing on-route charging, or if we just did dedicated, you know, like I know Winnipeg has a bus that just runs from downtown to the airport, and they've got pantographs at both ends. So when we were talking to our utility and street planners and everything, we didn't really have the opportunity to put pantographs around the city. So this is what our business goals was. We wanted to charge our buses for next day book out. So we use what we call opportunistic charging, and I'll get more into that in depth. But it's basically, if the bus doesn't need to be charged, we're not going to charge it to go on the next route. But if it does need charged to do its next block of work, we're actually just going to charge it so it's got a little bit in reserve and send it out. So we're not charging it up to 100% all the time. Let's say we've got multiple book outs per day because we have our AM peak and our PM peak. We've got a 24/7 operation. We wanted a safe operational model, and I put here no ground crews. We didn't want people running along trying to plug long umbilical cords that come out the walls into the bus to charge the bus. So we wanted it to be pantograph charging, so it was easier. A centralized control system, we call them bookers. So we've got someone sat in the office and it goes hand in hand with the diesel bus book out. And we wanted it to be scalable to full fleet electrification strategy because we got greenhouse gas reduction strategies like I think I'd like to say every city has. So we're working towards that goal. And as I said, 1-to-1 replacement of diesel buses and no fleet within a fleet. We have 2 production transit garages out of the 4 service garages, and they are Centennial and Kathleen Andrews. Centennial Garage has got 4 150 kilowatt overhead pantograph chargers, and our chargers are the red you can see up here on the roof of the building. And they were supplied by ABB. And within the shop, we've also got a 60 kilowatt plug-in charger because the bus may be recovered from being out in service with a high state of discharge. And to be able to work on it within the maintenance bays, we may need to charge up the batteries. So we've got a plug-in charger there. And they were supplied by Proterra. And operating out of Centennial, we've got 8 660 kilowatt Proterra buses. Centennial Garage was originally intended to be our research and development garage for the electric bus and the electrification of the fleet. But we quickly found out that we could use it as a fully operational service garage, which is why we've got 8 buses. And the reason there's only 8 is because with the power available in that garage, we can only run the 4 150 kilowatt overhead chargers. When we move over to Kathleen Andrews, which is our latest build garage, we've actually got 22 pantographs in there with the capability of having 26 pantographs. They're roughed in for another 4. We've got the electrical grid capacity to run them. So we've got 22 in there and 32 buses running out of that garage. Within the shops, we've got 6 plug-in chargers because we've got a big body repair section in there. So there's 2 chargers in the body shop, 4 in the mechanical repair. And I'd say we've got 32 buses. So there's a little picture of the overhead pantograph on its way down. and the one to the right is the Proterra plugin for the bus. And as you can see from these pictures, the pantograph does away with that, what I call the umbilical cord running from the charger to the bus. And because it's a 150 kilowatt charger, and we've only got 660 kilowatt bus, we can fully charge that bus in under 4 hours. Whereas if we were using a plug-in charger from Proterra, it would take 10 to 11 to actually charge that bus. So the bus performance, this was also part of our big RFP. As I say, we needed the bus to be a direct replacement for a diesel. And what we wanted is at least 80 to 90% of our routes being covered by this bus. And we're cognizant that the bus battery performance is dependent on weather conditions, whether we're using the heating or the AC. And I've got a slide just after this, which will actually show it. And in this one here, we're actually showing how everything talks, because it's more complicated than just having a diesel bus that you put out. So we got a system, an in-house system called ROB. And this is our runs on bus. And what that does, it tells us what the bus is doing, how it's, where it is and that. And then we've got our CCSS system, which runs the Apex, which is a real-time data for the bus in location and charging. So the Apex system identifies where our buses are geographically. When a bus arrives into the garage, the Apex system acknowledges that, and it identifies possible routes and provides a state of charge that each bus requires to cover that route. And that's based on the kilowatt hours per kilometer, which we've configured within the system. And as I say, the next slide, I'll go more into depth. So the route is assigned in Apex, and it's passed back to the ROB system. And when the bus is moved to a track in the garage, Apex can determine where the bus is and all the logistics around the bus. So we need to know where the bus is, because we've got 32 tracks in a garage with 350 plus buses. It could easily be lost in the mix. And the CCSS system kicks in once the charging commences. It captures all the detailed transactions during that charging event: when it started, when it stopped, how much energy was returned to the bus, the odometer reading and that, which we need to do to generate some of our reports. And then all of this data is sent to a data warehouse where our analytics team blends it with other data such as Environment Canada to help us get a better understanding of the impact of the temperature swings on our electric fleet. So this is what it looks like from our data. So I'm not going to go into too much depth on this slide because there's a lot of information. But what is important to us is when we look at the average kilowatt hours per kilometer here, and this is based on the Environment Canada's temperature. And then we go down to this in the bottom left corner, you can see when it's minus 25 to minus 29, we're using almost 3 kilowatt hours per kilometer. And when we get all the way to the other end of 25 to 29 plus, we're down at 2. So our optimal temperature range is in this really 5 to 24 degrees. But what we use this information for, as I said, we actually program that into the Apex system so that we can say when we're in this temperature range of minus 25 to minus 29, we're using on average 3 kilowatt hours per kilometer. We can't send that bus out on a 400 kilometer run. So by feeding that parameter into the Apex, it then assigns a bus with enough battery charge based on its consumption to a route. And just so we can nail it down to really what are we doing, we start using the consumption, the regeneration and charging information in here as well, so we know what each system's doing. So this one is just a scatter graph of what we were doing. And if we've got any outliers, like you can see there's one up here, it's just over 4. So we need to look at that and say, is there a data logger issue? Is it analysis errors? Or even is it aggressive driving style? Because we know the operator has a big impact on the regenerative braking and how he actually drives the bus. I can't talk for the other buses manufacturers, but with Proterra, we were able to dial in the acceleration rate, the regeneration rate of that bus. So we can set it out, you know, the bus can be like a Formula One car off the starting line, or it can drive, if we go to the other extreme, like a really slow person starting off from the line. So we picked a middle, so the bus still gets up and goes, and it's actually still quicker than a diesel. And our regenerative braking, we set at the middle, so it wasn't really harsh, but we captured enough regenerative energy from the going down hills that the operator didn't really need to use his brakes, and it also helped us charge the batteries. But while we're doing all this, we've also got to prepare for the future. You know, what is the future with this? So we know there's new battery technology coming, so we'll get greater range. We're increasing our bus to charger ratio from 1.6 to 1 to 2.5 to 1, because we found that these buses aren't using as much energy as we thought they were. So, and also by increasing to 2.5 to 1, we can actually get another 20 buses operating out of Kathleen Andrews' garage. So we've actually in the process of submitting a bid for another 20 buses from Proterra. And really that concludes my presentation. I wanted to keep it short. Hopefully it's give you an idea of what we're doing and gives you some food for thought. And as I say, I'm going to be here and type in your questions and we'll go through.
Thank you. Thank you so much, Norman. That was a great overview of kind of like where you started, what you've been doing, what you're doing now, and where you're going. So I really appreciate that. I have a bunch of questions that came up just from your presentation. So I'll definitely have them. Again, just a reminder to everyone, if you do have questions, please leave them in the Q&A section and we'll get to them. We really want to answer your questions more than anything. So thank you, Norman. We'll talk to you very shortly. I'm going to pass it now over to Pascal and Genevieve from STM in Montreal. So take it away, you two.
Hi there. Let me check my presentation. Oh, that's good. There we go. I'm sorry.
Okay, no worries.
I was looking for my presentation. So here we go. Is it good, Simon?
Excellent.
Yeah, all right. So hi, everyone. My name is Pascal Renaud. I'm a project director at STM. Today I am with Geneviève. Geneviève, do you want to say hi to the
good
people?
afternoon, everybody. I'm Geneviève. I'm the engineering manager at the STM.
So the two French colleagues from Quebec. So let me introduce you with our program to switch our depot to welcome our new e-buses in the future. So at STM, we have around 9 depots. Not of all will be transformed. The planning that you have here is to show you that we have a big challenge. Our first challenge is to buy only e-buses by 2025. This is the strategic plan from our board of direction. And also in Quebec, we do have this orientation from the Quebec government that they will subsidize only e-buses by 2025. So what we have to do on our side is to have a plan to retrofit our depot. So phase 1 will be 4 depots to retrofit from Bellechasse, Saint-Michel, Stinson, and East Depot. And we have also other depots that will come later this decade. So we will face our first challenge with Bellechasse. We will electrify Bellechasse by 2025 to have a fully electrical bus depot. So, and we might welcome our first e-buses for Bellechasse in 2024. We do have some project ongoing right now that we will show you in a minute. But just to tell you that Bellechasse will be our first underground depot ready to welcome our a fully electrical fleet of buses. So that's our first challenge that we will have at STM. And of course, the next challenge will be to electrify the other depot, of course. So I will pass on to Geneviève. She will explain you the impact on infrastructure, and I'll come back with some other challenge in a minute.
Thank you, Pascal. When we started talking about electrification at the STM, we realized that the impact on our depot was going to be major. So we did some studies to see first the impact on our electric capacity for each depot. And we realized that, as you can see here in the data, the required capacity in electricity for our depot, there's a major increase in for each depot. So in 2018, we started discussions with Hydro-Québec, which is our electricity supplier in Quebec, to evaluate if Hydro-Québec was able to feed us with these new capacity. And well, the answer is yes, they can feed us. So we made an agreement with Hydro-Québec. We want that our depot, we want the new connection required will be in 25 kilovolts, and each depot will be connected with 2 or 3 lines in redundancy. And also the lines will have to be coming from different substation or from different duct bank. We want that just to be sure that we manage the risk of power failure. We won't install any generator in our depot to charge the buses. So that's why we want a good connection from the grid with Hydro-Québec. Also, what we see is that each depot we need an extension in our existing depot in order to have electric buses. We need extension to be able to install the new electrical services, the electrical components, the chargers and their components, and also all the ventilation needed to evacuate or recuperate the heat generated from the chargers. So what you see here in gray is our existing depot is Stinson. And if we want to add electric buses, 100% electric buses in this depot, we need to extend. What you see in red is the space required to expand the building. We will also need to strengthen the structure and modify the lightnings to install the pantographs. We need to install all the conducts, the wires in the building, install the telecommunications component, and also add a catwalk in the maintenance area in order to access the upper part of the buses for the maintenance of the battery. So the impact on our infrastructures is important, and also it will cost a lot of money to modify our depot. We have a project now in the STM, in our Stinson depot. We will have 30 new Flyer electric buses. They are not in service yet, but all the infrastructures is in place now to receive all the electric buses. We have 12 150 kilowatt chargers. The chargers are from Siemens. And we also have 4 50 kilowatts chargers for the maintenance area. Maybe, Pascal, you can switch to the other slide. I'm just going to show some picture of the project. It's a pilot, so we are testing different technology. So we're trying a motorized reel. So you have a picture here of the reel for the plug-in for the bus. We also have pantographs, as you can see here. And we had to install a lot of conduct and wires in our depot. We have more than 30 kilometers of conduct and wires between the chargers and the pantographs. So this is, it was, well, a bit complicated to do all these work while the depot is in operation. With this project, what we see is that we're facing some technical challenges. The technology for the charging system is still new, and it is still changing. So what we do is in Stinson, we are testing 2 types of pantographs, one heavier than the other one. So we want to be able to see which one is better for the future project. We also see that there's no uniformity in the design criteria on the market now. The standards are still changing. So it's not always easy to do a good, to take a good decision for the future when everything is still changing. Another very important point is that the compatibility between the charging system and the buses is essential. So it requires a good coordination between those two points. Yeah.
All right. So also at Stinson, we do have some operational challenge that we faces when we start the project. Of course, all the technical part is very challenging to install all the equipment and doing that while the garage is still running and delivering the services. But also we feel that in a project like that, you have, of course, human change that you have to take into account when you do your project. So driver has new responsibility like connecting buses. So it's not difficult to connect buses, but when you ask a driver to do that while they were not supposed to do that, well, it's new. It's a new operation, so they have to make sure that the bus is plugged, or they turn the switch enable charge if we are under a pantograph. So they make sure that also the bus is well connected. So it's kind of a new in the process of taking your buses, unplug and plug the buses. Parking attendant and depot foreman, of course, they have a new system to supervise the buses. We have a SCADA system that we installed at Stinson. We installed that to, of course, push the information to the foreman, to the parking attendant, even to the maintenance guy. So they can be aware if there's an alarm, if there's a problem with one buses. Make sure that the bus is fully charged before putting the bus on a bus block. So of course, this is important for the teams. New procedure to reconnect the bus if there's an issue. So this is all new stuff that we have to develop with them. So new role and responsibility for them. Our infrastructure team, of course, they become the first responder if you have in case of a problem. So it's adding more tasks to the team. So it's quite new for them. They don't have any knowledge regarding charging equipment. So we have to do some training to them. Of course, we are supported with a contract which Siemens will be there in case of a major problem, but still those people will be the first respondent in case of a problem with the charger. So they will have to manage a new type of contract, and they will have to escort Siemens while preventive maintenance to learn about the task they have to do the maintenance on the equipment. So this is also new stuff for them to. So they have to learn and to do that. So it will maybe end up with it might end up with more people on that team for a fully electric depot. And also we have an operational center, a control center, which supervise all the buses on the road. And to those people also we put the SCADA system there, so they have an information on the alarm that is taking place, let's say in the garage or on the buses on the road. Some other challenges, of course, when you do electrification in a depot while your depot is still operating buses, as you can see, we have to close some alley. We close 2 alley at the time, but if we postpone our thinking and we project ourselves in a fully electrical depot, we might close more than 2 alley at the time. So the task force can install all the equipment faster. So we might end up with finding some space outside the depot to park our buses or to move our buses to another depot. So we have enough room to do the construction in the depot. So of course it's challenging to do that because our bus depot are quite full right now. I feel that a good coordination during the construction work is very important to make sure that everything is going flawlessly with everyone. So, and in a security, the security is always important there because the bus is, running close to the people who do the work. So this is very important. And we feel that every day or every 2 days we have a meeting with the team in place. So this is something that we add. Of course, the pandemic situation brought new rule on the field, so we had to be more careful about the security measure that we took. So it was quite challenging for our construction. And of course, good planning, it's good when you do this kind of project. So we feel that involving our operation team in the project since the beginning, it helps a lot to to bring more idea around the table and to make sure that all the change that you are doing is more accepted by the people. And I conclude my presentation with financial challenge because you know that installing all this kind of equipment, it's costing a lot of money. It's not only buying buses, but it's also we need money to buy all the equipment, to do the work, to do all the engineering. So in Quebec, we have like 3 available funding source. We have the PEV, which is the Green Economy Program from the Quebec government. We believe that Hydro-Quebec is one also of a source of funding. And we also have the federal government investment in electrification. So those 3 programs exist in Quebec. Well, the other one exists, the last one is for all the Canada, but of course we can probably took some money from that federal government program, but in Quebec we mainly use the subsidies from the Quebec government to do that. So we do have this kind of program in place. The program phase 1 is actually in the I call that the Quebec infrastructure plan. So it's almost a $670 million program for retrofitting 4 bus depot. Government has to understand that switching to electrification, it's not only, of course, buying buses, but it's also retrofitting depot. It took some time for them to understand that. We realized that now they really understand the need of that, but it took some time, of course, for us to, and a lot of meeting, a lot of discussion with our government. And for Bellechasse, we should receive our commitment to electrify the depot soon, but we're still waiting for that magic letter. But of course, it's part of the challenge, because since you don't have subsidies to buy all the equipment, well, you have to wait until you have the money to go tender, you know. So we thought that Hydro-Québec was one of the source to put money on the table, and it was at the beginning really clear that they were a good partner. But finally, there's some situation in Quebec that happened with this new law number 34. So now Hydro-Québec is no funding anymore, is putting no more money on the table for STM. So it's adding more challenge to, of course, to our program. Of course, the pandemic and all the costs of the pandemic doesn't help also. So financial, it's very challenging for us right now. So basically, that's about it. I think we did a good resume of all the challenge we had. And I think we're ready for the question.
Great. Thank you so much, Pascal and Genevieve. I really appreciate you walking us through some of the challenges and considerations that you guys took. I'll welcome back Norman to the discussion, and we have lots of questions, which is good. That's what I wanted to see. So we'll start taking them. I'm going to go back to Norman for our first one and ask a little bit. I'm going to generalize the question a little bit. The question is about winter conditions, and you mentioned up to minus 29, I think, in your buckets. And the question is about what about on colder days? What happens? You know, you get extreme temperature days and extreme situations. And maybe I'll generalize that question a little bit to just ask you, Norman, you know, is there something you guys do, or how do you consider kind of extreme situations where maybe the batteries are pushed to a bigger? You showed some of those outliers. Is there a way operationally that you're looking at how to manage those situations where that happens?
Well, I'd like to start by saying I think minus 29 is cold enough as it is. Actually, in Edmonton, to get below minus 29 isn't a normal day occurrence. Yeah, we did get down to, I think, minus 32. But really, the difference in performance between minus 29 and minus 32 is negligible. So if you looked at the graph and you really analyzed it, I was talking about 3 kilowatt hours per kilometer. At minus 29, it's only 2.85 or something. So when I said 3, that was the highest consumption rate we ever saw on our coldest day. But because it was an outlier, you know, below minus 30, as I say, is an outlier, so it wasn't really there. And yes, we did have the buses running this month at plus 42 degrees. But we, you know, when I was building this presentation, it was before I got that data, because some people may have picked up that my data and my presentation wasn't today. It's because I was building it for this, right? So we're still running this month, so we're still running data. Could I log into the system and get live data? Yes, I could, but we'd rather, you know, let the analytics team do the thing. So as I say, 3 is the highest consumption we've seen. And when we program that into the CCS system, as I said, we know not to send a bus out on a route. It'll consume more power than what's available on the battery. So it's a really smart system. It wasn't easy to get to that system. You've got Pascal and Genevieve going on about all the stuff that needs to be done in the background. And there is so much that in the time constraint we had, you know, we take up hours going through it. We really would. You know, we took over, I'd like to say, about 18 months before we decided on the bus. And it's like I said at the beginning, you don't start with the bus. You start from what do you want the bus to do? And that's the really important thing. And I seen there was So that'll answer that question, and we'll start working our way through. Otherwise, I'll be making you jump all over the place.
Sure. Thanks, Norman. That was a great answer. Thank you very much for that insight. I'm going to go to our friends at STM for the next question, and just ask them, and this is a question I have on my mind in general, but like, any of these projects you're looking at, it's a big transition. It's new. It's, a new area to get into for almost anybody. Maybe you can tell us about some, I think you touched on some of them, but some of the pain points you saw that came up during it, and how you kind of dealt with those as they happened.
You mean some problem we had during the project, right?
Yeah, something that may be unexpected that came up, or some.
Well, I think the major one was during the commissioning phase we have. Of course, starting all the engineering and defining what we want, starting from the needs, was challenging, but this is not the biggest issue. We probably had some more problem once we received the buses in September last year, 2020, and we had also some charger installed. So the first phase of the commissioning, when you plug your buses and you expect to charge, and you realize that you have lot of communication error, that was very challenging. It was very challenging because during that period, it was during the pandemic, of course, so not a lot of people were able to be on the field. So we tend to reduce the amount of people on the field. And we believe that to have a good commissioning phase and to make sure that everything is running smoothly is to have the supplier of the charger on site with the supplier on the bus on site. So when you plug your buses and you try to make them communicate and starting the process of charging, the operation of charging, when there's a bug happen, you need to be able to debug on the field. So you need to probably log into some black box in the charger or on the buses, so we can, of course, debug on site on time. So what we had is some problem is sometimes the people were not on site, so they were like under facility. So we had to took some logs, send some logs, they analyze, they send back the answer, we retest, they take the new log. So we lost a lot of time during that phase, a lot of time. So our lesson and learn was when you do debugging your charger, when you do the commissioning phase, you need both supplier on site so they can speak together, they speak the same language, and they can debug with the expert on site. So we lost so many time there. So that was the most challenging phase of the projects, I can say.
Thank you, Pascal. That's really interesting. When you think about this problem, there's so many different stakeholders, right? Like, I think that's probably a challenge that it comes up for anybody. There's so many different stakeholders and everything has to work together. So that makes a lot of sense to me. Mm-hmm. I'll go back to Norman. We'll ping pong back and forth probably. To ask you about, Norman, when we're looking at buses, you mentioned that would run on 80 to 90% of your routes, how that maps to your service blocks. And I think this is a really interesting question, is like, how did we then plan to, how does this impact your service planning and knowing how to deploy the buses?
So when I'm talking about routes, a route is made up of many blocks, right? So when we say 80 to 90% of the routes, it's the majority of our blocks. It's only our 400 kilometer plus routes, or the routes it's out there for almost 23 and a half hours, because with some buses it's out there. So with our planning and scheduling, we know what the blocks are, we know what the routes are. It's all fed in to the CCSS system. Mm-hmm. I wish they'd picked a different acronym for it. But it's all fed into that. So the system assigns the bus to that route, which is made up from those blocks. So that's why we said we needed a bus as a bus, whether it be an electric bus or a diesel bus. And those long outliers, we just restrict them from going into the system.
Yeah, that makes sense. So it's, if I can take what you said, it's you're saying you kind of dealt with that problem by starting with where you want it. Like, I think you mentioned this a few times. You figured out what you wanted at the beginning and you work back from that. So you said, we want something that will run on almost everything. So we're going to make sure we have the technology to support that, whether it's a long block or a short block or that kind of thing. Yeah.
And then, so this is where I went on to our opportunistic charging. So to give you an idea, and I'll just use rough numbers, and not get into the weeds. So we've got a fully charged bus. It's got 660 kilowatts, and it's using 2 kilowatt hours per kilometer, right? So that means we can do 330 Ks. So we send a bus out in the morning in the AM peak, and it could be out there for an hour. It could be out there for 3 hours on the AM peak. So let's say it comes back with 80% state of charge or 20% state of discharge. Depending on the manufacturer you talk to, one uses state of discharge, other one uses state of charge. So with 80% state of charge, using the 2, right, it's going to get really awkward because it's 80% to 660. Should have maybe picked an easier number. But let's say we've got 400 kilowatts left, and that gives us 200 kilometers. So if we want to send it out on the PM peak, to, like everybody knows PM peak, to get people back at home at night from the work, we can say that bus has got enough capacity and reserve capacity because that PM peak is only 300 kilometers long. But if it's 450 or 500 kilometers, we will charge the bus to a state that it's now at, we'll say 90% charge, because that's all it needs to do 500 kilometers plus have some in reserve. And remember, with the electric bus, it never gets to zero. Well, the Proterra doesn't. It always keeps a reserve charge to limp home.
Right.
So and that's the way we've designed the system.
Great.
And if it doesn't need a charge because it's got enough battery capacity, let's say it's only going out for 200 Ks, it doesn't need a charge, we will park it on a normal diesel bus track. So we've got the 21 chargers for the remainder of the buses because we've got more buses than chargers.
Yeah, it makes sense. It's all about optimization, right? And using your time effectively. So it makes a lot of sense. I'll go to Pascal and Genevieve for a question about if you considered, Norman talked a little bit about this, there are considerations for whether or not you have charging en route, right? If you have pantographs en route, or did you consider that? Is that something you thought about or something that you still thinking about or anything like that?
Well, we do have en route pantograph with our city mobility project. We have 2 en route pantograph. But when we start the electrification, when we start our committee that I put in place in March 2019, we sat down with Genevieve and other people around the table, and we said that, well, let's analyze how it costs to operate an en route charger versus a depot charger, and we simulated in our planning system that having charging en route, which will cause about 3 to 5 minutes every charging sessions. If you multiply that by the number of charging sessions you have to do with 220 lines, so 1,800 buses, we end up with an increase of costs at STM of around 16 to 19% of the operational costs. So we said, well, this might not be the best solution for STM that announced that electrification will increase the cost around 20%. That was the first conclusion. The other one was it's very difficult, like Norman said at the beginning of the presentation, that to install a high power charging station along the road, it's very challenging because you don't have the lot. The land is not belonging to STM. We do have some terminal, but it's clearly not to STM. So we have to expropriate is the a good word, expropriate, yeah, or to buy a lot. So you have to manage a bunch of contract along your lines to because you might rent some pieces of land to install your equipment. So all of a sudden you end up with you know, it's probably more easier to do that inside our depot.
Yeah.
And of course
also you have to bring the power to each pantograph, en route pantograph, instead of just bringing the power to one depot, and that's another argument.
Of course. So we feel that it's better to do that in our depot, and we own the land. So if we have to, let's say, add, like Geneviève said in the presentation, if we have to add another building, you know, close to the existing one, it's easier when you are, you know, when you own the land. So yeah.
Thank you very much. I'm going to, we're getting down to the end, so I might do one more question for Norman, and then I think we'll wrap things up. And I'm going to maybe ask you, Norman, the similar question to what I asked Pascal and Geneviève at the beginning, which is, if looking back now, because you guys are now, you've been running it for a year, maybe, I'm not sure exact time, I think it's more than a year now, if I remember correctly. Looking back at the whole journey, is there anything you can say that you would have done differently if you, with the hindsight you have now, or maybe a hiccup that you can say, you know, this didn't go exactly as planned, this is what we would have done differently?
Yeah, it's a very valid and very good question, which is difficult to answer. I think the biggest headache, and I think we've got it resolved now, is because we're using this CCSS system and Apex to work out on the charging of the bus. As we drive down our tracks, and we've got all our pantographs, as you've seen from the photograph, you know, the 6 deep and the 4 or 5 wide. As the bus is going under a pantograph, and it's all done through Wi-Fi, it's confusing the pantographs. And I don't know if STM's run into this problem yet. So as the bus is running down, and let's say it's running down let's make it really awkward. It's running down the middle track of 5 tracks. So it's passing 2 tracks either side of 12 pantographs, and it's going to the front pantograph of the middle track, if you can visualize that. As it's passing all these pantographs, it's telling them, hey, I'm a bus and I need to be charged. So by the time it gets to the pantograph it needs to be at, the system is going, okay, which pantograph am I deploying if none are deployed? But the beauty of the Wi-Fi and the way the ABB system set up, and as I say, we're working our way through this and we think we've got it. We've got different frequencies we can use, and I'll just call them A, B, C, D, and E, because I can't remember, are they 124.5 or whatever it is. So we're trying to go, okay, this track is A, this one's B, this one uses C and D and E. So they're using different frequencies to try and eliminate that. And then we also reduced the Wi-Fi signal strength by 25%. And we're finding that is resolved, I'll say about 80, 90% of the problem. But this was one of the big asks we had at the beginning of our RFP, was that we decided we were going for long range, in-depot charging, using pantographs. So whoever we went with had to come up with that solution. And we were groundbreaking on this because no one else had even gone where we were going. And I think that has been really our biggest problem to date to try and overcome, is getting the bus to communicate with the right pantograph, to tell the booker shack who's doing all the charging to initiate the charge in that it is under the right pantograph.
Right. Yeah, that's interesting. maybe you know, we're really tight on time. We're almost at the end, but maybe very quickly I can ask Pascal and Genevieve if you guys have seen a similar problem with your testing.
Genevieve, you can complete my sentence, my answer if you want, and no worry. But what we have at Stinson is we of course have this Wi-Fi. Normally we have this issue when we at City Mobility in the city center of Montreal, when we park two buses close to each other, the session stops. So to make sure that we learn from that, we have installed RFID antenna at Stinson. So what we have now is we have a combination of the Wi-Fi and the RFID antenna. So in the program of in the protocol SAA G3105, what we have is we check with let's say the Wi-Fi, we detect the bus, and then we have to make sure that the right bus is under the right pantograph to initiate the session charge. So it's helping us to have this to resolve this kind of problem. But we had some also issue with, you know, the beam of the antenna, le gain de l'antenne, the antenna power. I don't know how you say that in English, but there's the power of the antenna, I would say. Okay, so we have to adjust that to make sure that the antenna, the Wi-Fi antenna, is not detecting the other bus beside the one we have. So of course we have to struggle a little bit. We perform also a study where we analyze the interference of all the Wi-Fi in the depot to make sure that, you know, the Wi-Fi from the charging session is not interfering with, you know, the Wi-Fi from the depot. And we are with Siemens right now. We have data logger at Stinson to make sure that, you know, we find the because with the RFID we also have some little issue too. So we have to make sure that the RFID is well positioned under the bus. So we are a little bit offset right now on some positions. So we are detecting two alley. So yes, I confirm that it's a challenging it's a really challenging operation, but we feel that we will learn a lot with Stinson. That's why we have installed you know, pantograph close to each other to make sure that we can learn from interference, you know. So, but it's a challenging. So Norman, I might contact you one time soon.
Yeah. So sorry, just to go back to Pascal, we've also got the RFID as well, and this is where we're playing with them both. Yeah, but it'll be a great conversation offline. Yeah.
No, this is great, and it shows like this topic how, like, just one subtopic, how much conversation there can be around just one little area. They're so rich in discussion and information. So I thank you, everyone, all of our panelists, for your time and your insights. We only got to a fraction of the questions that were submitted. So we will save the questions. I don't know what we can do with them, but we're going to save them just so we don't lose them. And we can, you know, CUTA we can talk amongst ourselves offline, maybe about what we can do. But there's a lot of good questions that we didn't get to. But like I said, there's just so much here that I think people are curious about and want to learn about. So thank you, Pascal. Thank you, Genevieve. Thank you, Norman, so much for your time and taking time out of your week. I know there's a lot going on right now, so we really appreciate it, and we're hoping you know, we'll continue the conversation going forward in the future in this topic more and more. So thank you very much, and yeah, thank you to all of our attendees that were willing to join and take time to listen to.
So thank you for this opportunity, and I hope we give you, as I say, some food for thought. Yeah. And one thing, I was reading the questions, and there wasn't a lot about the RFP, but one thing I would strongly recommend, if you are going down the RFP process, hire an external fairness monitor to make sure that your RFP is being monitored externally and it is being done fair. That's one of our strongest recommendations.
Great, thank you. we might, maybe at another time, we'll ask you more about that too. Yeah, and thank you, Pascal and Genevieve as well.
Yeah.
Thank you.
Thank you very much.
Thanks, everyone.
Bye-bye.
Bye-bye.